Hey there, Russ here. Welcome back to the shop. Well, I finally did it. As you can tell by the title, I have this Drok, D-R-O-K. It's a DC boost, 15 amp. Input is 8 to 60 volts. It converts DC to DC, and the output is 10 to anywhere from 10 to 120 volts. Now, it's a boost converter. It means that if you're putting in 24 volts, like my lab bench supply that I made, it only goes up to 24 volts. If I wanted to get above 23 volts, I would plug this in and then start using. I can reset this to those volts. If it's less than 24 volts I'm working with, I would not use this. It won't go down based on the amount of input voltage that you're putting into it. But the output will go from 10 to 120 volts DC at 15 amps. I have to tell you, that's a lot of voltage. And that's actually more than I'll probably ever need on the DC side. Anyway, after I made this box with the hinges, if you remember here just an episode or so ago, and since then I have now got this all set up and ready. It actually works. I have these are my test leads going in. These are my test leads coming out. And the meter is right here. So if I wanted to, let's hook this up and take it for around the block and show you what it can and can't do. There goes my foghorn. So I'm going to turn this on. Now you'll notice on this, whoops, I'm going to need my leads. Let's get my leads out. Oh, they're out. They're right here. So I'm going to take these and plug them in. Oh, and let's turn this one on. And the only reason I'm using these leads instead of hooking up directly is I really didn't make these long enough, but it's not a big deal. Now I can take these and hook them up right here. And I can take these two, and what we're going to do is hook them to a voltmeter. This is the output. And I'm just going to stick those right into the dog hole so that they're out of my way and hooked up, and I don't have to worry about something accidentally shorting out here or anything like that. Anyway, so I've got it hooked up. I have it set to 23 volts coming out with 10 amps. And if I want to turn this one on, I simply hit my output, and that comes on. Let me turn my voltmeter on. Now this is the one thing that's strange about it. It's putting out 23 volts into here, but I don't have it turned on. And I'm reading 22.73 volts, which is about 250 millivolts less than here. So that's probably the drop off. But the confusing part is I wouldn't have thought I would get any voltage when this isn't on. If I turn it on, it's set to 36.5 volts. So if I turn it on, I am outputting 36.69 volts. So I'm going to round this off to the volt at this point. The point volt isn't really relevant to what we're doing. So anyway, it's on, and I'm doing 36 volts. If I want to go up or down, the two center buttons will allow me to drop it or raise the voltage up. And once I do that, that's what it's reading. And then I can turn it off. Whoops, that just switched it over. To turn it off, you hit this button on the far left. And now I turned it off, and this goes back to the 22 volts that is being input in from this. If I turn this off, then this drops off to 0 volts. So you get good control. Let me turn it back on. And if I want to set these volts, right now it's off. There's no lights lit up. And with it here, I can sit here, hit my set button, set the 12. I can set the amps or the volts. Let's say, for example, that was down. This one's up. Let's go up to 50 volts. So we're at 50 volts. And now when I turn it on, I'm reading 51 volts here, 50.8 here. So it's still within that 250 millivolts of each other. But it's now kicking out 51 volts instantly instead of the other. So it works just like it's supposed to. It works really well. I can't complain. And what's really cool about this, if I wanted to, check this out. Let me turn this off. Let's take this off. And we'll put this back down here out of the way. Yep. Let me get these out of the way. So I'm just going to put them in there for the moment. It's still plugged in. But now, this is dropping off the voltage from the capacitors in here. But there's another thing you can do here. If I wanted to, I can take any DC source. Let's check it out. Just a little Ryobi battery, positive, negative. So if I hook this up to the positive, hook this one up to the negative, and I'm now putting out 19.3 volts from this, because that's what this thing has in it, capacity-wise. If I turn it on, I'm still running 36 volts out of it, off of my Ryobi battery. Now, I don't think I'd want to pull 15 amps off of it, or even 10 particularly. But I can adjust the amps on this thing to run it off. I can run it right off this Ryobi battery. Not as long as I could off the other power source, but so you can run this off of any battery. Then I can take it and check this out. This is the other thing that's really cool about this, is if I wanted to, I set the volts, and let's go up. $60, $70, $80, $90, $110, $114 volts. It goes up to 120 volts. Now when I turn this on, whoops. I didn't change it. No, I did. It's at 114 volts. And that's what it's putting out, 114 volts. So I'm pulling 114 volts out of a little Ryobi battery. What's amazing is whatever I hook this up to, as long as the amount I'm getting out is higher than the source voltage, I can go all the way up to 120 with virtually any DC voltage. So anyway, but that's it in a nutshell. I'm actually quite impressed. And now I finally got this thing out of my drawer, and I got it here to where I can hook it up and use it. So now this thing's going to be of use. So it's nice to add this to my arsenal of different meters that I may need to do some particular type of unusual experiment or test or whatever I want to do. So I'm actually very pleased with finally getting this thing built up. Anyway, I wanted to take a minute and show it to you. There's really nothing to it. I did put a hole in it right there, which lines up to the fan. There's a hole in the bottom so that the air can actually circulate through it, even if the box happens to be closed while I'm running it. So I could set it up, turn it on, and then just leave the thing closed if I wanted to, and let the thing run. And if it gets that hot, the air will vent it, so it'll keep it from overheating. Anyway, I think it'll work well. I haven't put it through any super paces on the amount of amps coming out. I may do that in the future, but I do know at this point it does work, and it seems to be pretty accurate as to what the voltage is going in or out. It always seems to be within that 250 millivolts or less, the input versus the output. So I think maybe that's just a drop off. Anyway, I think it's a good little unit. The Drok boost converter. Drok makes pretty good equipment anyway. I've had several of their different pieces, and I've never been disappointed in anyone. And other than the quirk that this thing is going to show you what the source voltage is when it's off, is the only thing, because that means that this thing is always live once you turn that on, take power to it. And you have to be just aware of that. I could have put an on and off switch on it for the output, but I decided to keep this as simple as possible. Also did the instructions. I put a couple of pieces of hard wire here. This is just solid core 12 gauge or 10 gauge wire. And I just put two of them, drilled a hole here and here, shoved it down in there, and it's tight in this hole. So this thing is not going anywhere. And I can just store this right here with the instructions on how to use it if I need it. And I have it set here to where you see the specs instantly. So when I open it up, if I'm trying to remember what I can do with this in output, I got that information right here quick. Anyway, this should be a great little unit to have around my shop. And I'm kind of anxious to see what I can do with it. But I thought I'd share it with you since I got it done. If you have any questions, any suggestions, let me know. I went with alligator clips instead of leads because that way these will hold 15 volts. This will probably put 15 amps out a little better than if I was using banana clips. Those usually only have about a 10 amp rating. And even though I probably will never go over 10 amps on anything that I'm doing, it's nice to have that little bit of extra. And quite honestly, this puts out 15 amps, my lab power supply. So if I want, I can take my lab power supply now and actually boost it up if I wanted to. So that solves that minor problem there that I had of doing that. And I had this all along. I forgot I had it. So I ran across it here a couple of 3 days ago. Well, a little longer than that. And I've been thinking about it, and I realized that it actually fits in there pretty good. Now, I will tell you that not only the holes are drilled, but to put the wires in, these is 10 gauge wire. And I drilled the hole so that this slips through that hole, but it's a very snug fit. So it's not pulling on those cords at all. It's stuck in this. If I thought there was a problem, I could put a white tire on a tie on there if I wanted to, but I don't think that's really necessary. They are both pretty much sturdy, and they will not pull on the connections. So the fewer connections, the better. And I think this will actually work out pretty good like this. If I want to change it to something else, I can easily do that because nothing is glued down. This plate, this thing's not even glued down. It's held in there by these wires just sitting there. And it seems to be pretty sturdy. So, anyway, that's it. I can't complain. I'm very happy to have it. If you have any questions or any thoughts about it, let me know. I do like to read all of your comments, so don't be afraid to leave them. If you learned something here, you like this video, hit that like button. Lets me know I'm doing something right. Most importantly, though, please come back again because I'm nowhere near done. Thanks, and we'll see you guys again very soon with another project.